Hello everybody, welcome back to the lecture series on EC368 Robotics Module 5. In the previous two lectures on velocity kinematics, we had studied the various derivations required for forming the Jacobian matrix based on the forward kinematic solutions. Reviewing the Jacobian matrix, we know that the Jacobian for an n-link manipulator is of the form J is equal to J1, J2, etc. up to Jn. A gentle reminder to you all to please keep your notes along with you so that the derivations are clear when you are watching the video. Where the ith column of the Jacobian Ji is given by Ji is equal to Zi minus 1 cross On minus Oi minus 1 and Zi minus 1 if the joint I is revolute. If the joint I is prismatic, then Ji is very simple. It is Zi minus 1, 0. So this term is the JV term and this term is the J omega term. Here again is the JV term and the J omega term. Now let us look at a very simple example of a three-link planar robot or a manipulator which will be given in the figure. And we are supposed to compute the linear velocity v and the angular velocity omega of the center of link 2. So in order to compute v and omega, we had seen in lecture 2 of this series, Velocity Kinematics Part 2, we saw that v omega is equal to jv j omega. That is your Jacobian matrix into q dot. So now we need to find out, for finding out v omega, we need to find j into q dot. Now since this is a three-link manipulator, we have J1, J2 and J3. That is, each column of the Jacobian matrix we know corresponds to one of the links. So now we are asked to find out v omega for the second link. Okay. So we look at J1. J1 is associated with a revolute joint. So Zi minus 1 cross On minus Oi minus 1. Let me say Zi minus 1. Now as J1, I is 1. So Z0 cross. Let me call On as OC, the center over here. Okay. Minus Oi minus 1. 1 minus 1, 0. Alright. So J2 is equal to Z1 cross OC minus O1. What about J3? J3 is now not important to us. J3 is associated with link 3. We are asked to find out the velocity and linear and angular velocities associated with the center of link 2. So the movement over here is not going to affect the movement over here. So we can take J3 is equal to 0 in this particular problem. Now let us look further and see how we can determine this Z0, OC, O0, all those things, how we can determine in the next example. Now we have always studied about the two-link planar manipulator as a preliminary study to understand kind of forward and inverse kinematics and all. So let us again for the Jacobian study a two-link planar manipulator and determine its Jacobian. So we had done this in module 4. The forward kinematics was used to determine T1 with reference to the base frame 0 and T2 with reference to the base frame 0. So we are taking that derivation from module 4 over here, and final solution of the forward kinematics equation is presented here. So T10 we had derived it like this, and T20 we had derived it like this. Now considering that it is a two-link planar robot, your Jacobian will consist of J1 and J2. J1 and J2. Now both the joints in the two-link planar manipulator are revolute. So you will write it as Zi minus 1 cross On minus Oi minus 1. So like considering J1, it will be Z0 cross On. That is at the end. So you have two links. So the end of that you have O2. So two joints are there associated with that. We have 0 and 1. So the next one will be the end of the link or the point where the wrist should be attached. That will be O2. So Z0 cross O2 minus O0 and Zi minus 1. So Z0. Similarly, J1. This was J0. This was J1. Now we are looking at J2. Now we look at J2. J2 will be Zi minus 1, 2 minus 1, 1 cross O2 minus O1, and this will be Z1. So this is I is equal to 1, that is J1, and this is I is equal to 2, that is J2. Now, how to find out all these different things? They are found out from the solution to the forward kinematics equation. Now, O0 is the origin of the base frame that is taken as 0, 0, 0. That is the origin, the starting point. Now, O1, where is O1 taken from? O1 is taken from this T10. We know that every transformation matrix, this 3 cross 3 portion is the rotation. This 3 cross 1 vector denotes the position of the origin. Okay. So, here is your O1. O1 is A1, C1, A1, S1, 0. That is what is written here. So, from the fourth column of T10, I will get O1. Similarly, O2 can be got from the fourth column of T20. So, O2 will be this thing. Okay. A1 C1 plus A2 C1 2, A1 S1 plus A2 S1 2, 0. So, this is your O2. Now, continuing, we have to find out Z0 and Z1 and all. No? So, Z0 is your base frame's Z-axis. So, we know the unit vector that is associated with the Z-axis K, that is K is 0, 0, 1. Now, where is Z1? Now, if you look in your previous slide, there is T10. So, that T10, I told you the first 3 cross 3 section is the rotation matrix. The first column in that rotation matrix denotes the x-axis. The second column denotes the y-axis. And the third column denotes the z-axis. So, we just have to take the third column of T10. So, the third column of T10, if you look at your notes, T10 third column is 0, 0, 1. Okay. So, now itself we have got j omega 1. J omega 1 was Z0 and j omega 2 was Z1. Here is your Z0 and here is your Z1. So, j omega is already done. J omega is this 0, 0, 1 Z0 and this 0, 0, 1 that is Z1. Now, we have to find JV. So, let us look at JV1. JV1 is Z0 cross O2 minus O0. So, what is that? 0, 0, 1 cross O2 minus O0. O0 very simple. It is 0, 0, 0. So, we just have to take O2. This was the last thing that we had derived in the previous slide. So, we just take O2 and do the cross product. I hope all of you all know how to take the cross product. So, the first thing that we get over here is 0 into 0 minus 1 into this term. So, that is the first thing. Okay. So, 0 into 0 minus 1 into this term. Now, what is the second term? The second term is 1 into A1 C1 plus A2 C2 minus 0. That is your second term. Now, what is your third term? Your third term will be, the third term will be 0 into this minus 0 into this. So, 0 minus 0. So, you have got this answer and that is the first JV1. This is JV1. Now, what is JV2? Z1 cross O2 minus O1. So, Z1 is here. Okay, Z1 is here. What about O2? O2 is, you have got O2 minus O1. So, O2 you have got already over there in your previous slide. Minus of O1 in the previous slide we have found out. Subtract the 2 and then you get these 2 over here. Do the cross product and you've got this answer. So, your JV1 is this term. Okay, it is written here. And your JV2 is this term. It is written here. What is J? J is JV, J omega. So, arrange this over here on the top over here. Okay. So, the first 3 rows and 2 columns, they are coming from JV. And the next 3 rows and 2 columns are coming from J omega. So, this is the Jacobian for the 2-link planar manipulator. Now, problem 2 is a bigger problem. Derive the Jacobian of the Stanford manipulator with a spherical wrist. This again, we have done the derivation in module 4. That forward kinematics problem has been solved for Stanford manipulator. So, for a spherical wrist, what is the property of a spherical wrist? All the 3 axes, if there are 3 joints in the wrist, all the 3 axes, they intersect at a common point, a common origin. Let us call that common origin as 0. So, now we know the Stanford manipulator has 3 joints in the manipulator section and in the arm, and then it has in the arm and it has got 3 joints in the wrist. So, now we have got how many columns can you see? 3 for the arm and 3 for the wrist. So, totally 6 columns. So, that is why we said 6 cross n matrix is the Jacobian. So, n is equal to the number of joints. So, in our case, it is going to be a 6 cross 6 matrix. Okay. So the first joint in the Stanford manipulator is the revolute. So it will be Zi minus 1 cross, what is the last one? You have 5, up to O5, no, 6 joints, O0 to O5. So the last one will be O6. So Zi minus 1, that is Z0 cross O6 minus OI minus 1. So, and this will be Zi minus 1. Similarly, this will be J2. Okay, this has to be changed. This actually joint 3 is prismatic. Okay, so joint 3 is prismatic. These two are revolute joints for Stanford. This is a prismatic joint. So in that case, we are seeing that this particular one will be Zi minus 1, 0. So this is joint 3. So Zi minus 1 is 3 minus 1, Z2 and 0. This is revolute again. Now this is again revolute and this is again revolute. Only thing is, you see over here all the, instead of OI minus 1, we have put this 0. Sorry, not 0, the O, that is the wrist center over here. Now the derivation for this you can follow in a similar manner to problem 1. You can follow it in your notes. Just as like we had seen before, we take T10. T10 is going to give you your O1 and O2, I'm sorry, O1 and Z1. O0 and Z0 are for the base frame. O0 will be 000, Z0 will be 001. Now your Z1 and O1 you will get from T10 and so on. So please continue following the derivation in the notebook. Now moving on to the problem 3, the Jacobian of the Scara manipulator. Now the Scara manipulator that we had done in module 4 had a, we had seen there are 3 joints in the arm and 1 revolute joint in the wrist. So just like we wrote before, Z0 cross, now the 4 joints totally, no? So O0 to O3, the last joint, origin we are going to call as O4. So Z0 cross O4 minus O0, Z0. Z1 cross O4 minus O1 Z1, and again the third joint, joint 3 is prismatic. So since it's prismatic, this will be Zi minus 1, joint 3, no? So Z2 0, and this is again revolute. So since the Scara manipulator derivation is a little more compact, I'll just continue that in just for clarity's sake. So from our forward kinematics derivations that we did in module 4, we've got T10 is equal to this, T20 is equal to this. So O0 I had already told you is 0, 0, 0 base frame. Okay, Z0 is equal to 0, 0, 1 base frame. Now O1 I had told you we have to take it from T10. So this is your O1. A1, C1, A1, S1, 0. So this will be your O1. Now where you get O2 from, O2 is got from T20. So this is your O2. No, sorry, this is your O2. What is this? A2, C12 plus A1, C1, and then this is A2, S12 plus A1, S1, and the last one is 0. So you can see that we have got that here. Now Z1, where do you get Z1 from? Z1 is got from the third column. So O's are got from the fourth column. The Z's are got from the third column. So O's are got from the fourth column and the Z's are got from the third column. So Z1 is from the third column of T10, so 0, 0, 1. Z2 is got from the third column of T2, so 0, 0, minus 1. Continuing our derivation, we have T30 over here. From T30, we can get O3 and Z3. You know that the O's are got from the fourth column, so this is your O3, and the Z's are got from the third column, so this is your Z3. Similarly, we can do T40. So T40 is T30 into A4. For the sake of compactness, I have not done the entire multiplication because we just need this column and this column of the final result. So doing the multiplication to generate only the third column and the fourth column, I have got O4 to be this and Z4 to be 0, 0, minus 1. See, this is not clear. Please keep your notes for reference. Now calculating JV1. JV1 will be Z0 cross O4 minus O0. We have got all the values required. So computing that JV1, we have got this. Now JV2. JV2 is Z1 cross O4 minus O1. Computing that, we have got this. Okay, now JV3. JV3, remember joint 3 is prismatic. So JV3 is simply equal to Zi minus 1, that is Z2. So Z2 we had calculated in the previous slide was 0, 0, minus 1. So this is Z2. Now this is JV3. This is for the third joint. So this was JV1, JV2, JV3 we have calculated, and this is JV4, sorry. JV4 is Z3 cross O4 minus O3. Computing that, we have got 0, 0, 0. So we have placed here JV1, which is JV1, this is JV1, then JV2, this is JV2, then this is JV3. JV3 is equal to Z2, which we have got from the previous slide, and this is JV4. JV4 is this one. Okay, so this, now we have got here J omega 1, J omega 2, J omega 3 and J omega 4, which we had computed in the previous slides.